Okay, the lottery problem. We talked a little bit about this in class. This first question I think is off, so I want to just make a quick video. If the grand prize is 12 million, find and interpret the expected cash prize. That's how much money they would just give you without considering your dollar. But this question says if a ticket costs $1, what's your expected profit? So that does consider your dollar. Okay. So if I open this in StatCrunch, this is what you get, these first two columns. And this is how we set this up in class. We would consider our dollar cost, right? I lose a dollar at 97% chance I lose a dollar. Or the other way to interpret it is I win $0 at 97% of the time. It's the same thing. This way considers that you spent a dollar, this way doesn't. So the way this question is worded, I think it's poorly worded. If a ticket costs $1, what's your expected profit? That should be considering the -1. Now you could use these two columns, or you could calculate the expected prize and then subtract your dollar. You should get the same thing. All right, so let's see which one. I think when we did this in class, it really should say what's your expected cash prize, like not considering the fact that you spent the dollar. But let's find out. So I get a mean of 0.3136. 0.313. Okay, so that's not right, really. That's your expected cash. Well, I'm sorry, that is right. That's your expected cash prize. So that's right the way it's worded. But this shouldn't even be here. It just doesn't make sense. I think it's a typo. Okay, so expected cash prize would be what are they giving you without considering your dollar. What is the interpretation expected? If you played the lottery many times, on average, you will profit in the amount. It's not profit. You expected cash prize. If you played the lottery many times, on average, you will win the expected cash prize. That's what that one should be. This just shouldn't be there. That's just really, I think that's an error. It should be, they're talking about the cash prize, not the profit. And I think later we're going to talk about there you go. So this is the expected profit. So there's two ways you can do this one. Since we got the prize, we can just subtract $1 from this, and it should give us our negative value. It should be -69 cents. Or if we did it in the way we did it in class, where you consider the cost first, which is typically what you would do. You're interested in your net gain or your profit. Let's see if this it should give us 31 cents minus $1, -61 cents. If I had to type these in myself, I just subtracted $1 everywhere. So now I'm going to do the same thing, only I put my new data in these other two columns. And there's your -69 cents, right? If you round to the nearest cent. So you can get there one of two ways, the way we did it in class, or you can do the expected prize and then subtract $1, which I don't like, but you can do that if you want to use their data. That's fine. And then let's see. What is the standard deviation of the cash prize? So that should have been so you just got to distinguish between the two, the cash prize and the profit. So I think for the cash prize, then I'm back to the original data given. And that gives me this number, 1070.4. Okay, and I think, the questions are fine except for this part. Right, expected profit from one ticket. That just shouldn't be there. It should be the expected cash prize is 31 cents. The expected profit from one ticket, that question should be down here. Okay, so I know that's confusing. What does this value suggest? That's a pretty big number. I think it's a wide range of payouts. And then what? Okay, I want to talk about this one too. So this one, we didn't do something like this in class, but so we're going to go back to the grand prize one. So that's my data over here. That's my columns, the original data that they give us, because they're asking about the grand prize, not the profit. So I'm looking at this, and they want to say, well, remember, right now, if you calculate this, expected value is 31 cents. But if you want to be profitable, or let's read the words. So you can expect a profit. How much should the prize be so you can expect a profit? If you're going to use these two columns, the original data, then your expected value would have to be greater than 1, greater than the dollar you spent. When you use these two columns, your expected value would have to be greater than 0, since we've already considered the dollar lost. Okay, so you can do it either way. But if you use these two, the given data, then our expected value, we need to know what this is, right? So I'm going to remove him because they're saying, well, what should that be? So the formula I have to set up would be, remember what the computer's doing for your expected value. It's taking this, multiplying it by the probability, plus then the product of these two, plus the product of these two, right? So you'd have to set up a little algebra equation to answer this last question, where x is your value for that, for this cash prize. Saying how big does this have to be for you to make money? So it would be x times the probability that goes with the big prize. So you're not changing any of that. So that's x times x times 0.1, 2, 3, 4, 5, 6, 7, 8. 7, 8, 5. That's the probability if I don't use scientific notation. Plus, and then it's all of these guys, right? This times this, plus this times this, plus this times this, right? So I would say plus the 200,000 times this little probability, 1, 2, 3, 4, 5, 6, 3, 8, plus, and then all of those guys, right? Each winning times the corresponding probability, and so on, all the way down to the last one, which you still compute even though it'll be 0. Okay. This is what you do to get the expected value. This is what the computer did for the previous problems. It multiplied this by this, and then it added all these products. So if they're saying, well, what does the prize have to be? You would say, well, we'll call it X. And if you want to be in the profit, then you have to make more than the dollar you spent. So you'd have to solve that inequality, which is a tough one. All right. But you could use the calculator or the computer to do all of these ones, right? And then and then you solve this simple inequality. This plus all of these, you could just do the expected value. You could delete these first two and get the expected value for this, and then solve this inequality. Okay, so that last one's a little tricky, but I hope that makes sense in terms of the difference between expected value of a cash prize and expected value of the profit.